Welcome to today's Lunch and Learn with Enphase, Lights Out Automation with AI, transforming document images to searchable, structured information, featuring Mark Gross, President of DCL. I'm Marcy Granahan, Director for Enphase, and I want to thank you for joining us today. Our Lunch and Learn series is held on the fourth Tuesday every other month, and the series is free for Enphase members and available to non-members at $65 for each session. For those of you that are tweeting today, you can use hashtag Enphase to join in with your comments or retweets. And to ensure that you don't miss any announcements of future Enphase events, sign up for our bi-weekly newsletter, Enphase Advances. So before we begin today, I'd like to quickly highlight some important features of our Zoom platform. At the top left of your screen, you should see 4 user controls: audio setting, Q&A, chat, and raise hand. If you're experiencing audio difficulties, you can test your speakers or adjust the volume by clicking on audio settings. Please note that today's session will be held in listen-only mode. Once our speaker has completed his portion of the program, the system allows for live interactions between you as an attendee and the speaker for the purposes of Q&A. If you're using a telephone or headset connection and you want to ask a question live, simply raise your hand when prompted, and Enphase staff will take you out of listen-only mode so you can ask your question directly to today's speaker. If you're not using a headset or telephone connection today, you can ask your question by clicking on the Q&A. A Q&A window will appear in the center of your screen where you'll be prompted to please input your question. Be aware that your identity, as well as any commentary or questions posted to the Q&A box, will be visible to all unless you check the Send Anonymously box. Once your question has been answered, you can close out the window by clicking on the X in the upper right-hand corner. The chat feature has been disabled for today's event. However, if you need to reach Enphase staff, you can post it in the Q&A box and we will respond back to you privately. During the event, the presenter may ask you to raise your hand in response to a particular question. Let's test that now. Please raise your hand if you can hear me. Wonderful. All right, they're all coming in. Thank you. Okay, so at this time, I'd like to introduce today's speaker, Mark Gross. Mark is the president of DCL, an organization that has been helping organizations transform their content to smarter formats for over 35 years, including XML and HTML conversion, metadata enrichment, and web scraping using the latest innovations in machine learning, artificial intelligence, and natural language processing technology. DCL has a monthly newsletter that brings industry news on topics such as this direct to your inbox. You can visit them at www.dcllab.com to sign up. Mark is a recognized authority on XML implementation and document conversion. He also serves as project executive with overall responsibility for resource management and planning. Prior to joining DCL in 1981, Mark was the consulting practice of Arthur Young & Company. Mark has his BS in engineering from Columbia University and an MBA from New York University. He has also taught at the New York University Graduate School of Business, the New School, and Pace University. He is a frequent speaker on the topic of automated conversions to XML and SGML. So welcome, Mark.
Okay, thank you. I am trying. Okay,
Perfect.
Got it. Okay, thank you, Marcy, and thank you everybody who's on this broadcast. So we're going to talk about lights out automation on a big project we've been working on for, actually it's in its 4th year now, and I think it'll be of interest to lots of people on this. I've personally been working on how to better transform content for the past 36 years. Because content isn't just a bunch of pages and text, it's the information that's in those pages that's is important and getting more and more important. I mean, it's always been important, but the last 5 or 10 years, there's been 2 major things that have really changed the industry. One is there's more and more content out there to sift through. We never really thought about terabytes and zettabytes till a few years ago. And now there's new intelligent tools around to sift through that content that have become much more robust. But they're also it makes it, all those tools are very needy. What do I mean by that? Artificial intelligence and machine learning and all those technologies need well-curated, structured content to really operate. It's not. It'd be nice if they, just you pile in 1 million pages and everything worked great, but it doesn't really work that way. At least not now. Maybe in the next 50 years. And this really fits into our mission, which is to structure the world's content to make it consumable, and make it consumable by the latest technology, whatever that is. Today, that is, a lot of it is AI and being able to deal with large amounts of data. So I'm going to be talking today about a live project where we're taking unstructured image content, transformed into structured content, untouched by human hands at a rate of 2 million pages per month. First, just a couple of minutes, 2 minutes on what our overall services are and the kind of customers we have, and then we'll get right into the main event. Just in terms of what our services are, most people think of these first two boxes as what we primarily do. Digitize OCR, those are the traditional things that you did in converting information, and then transforming it into XML and HTML. Not so much SGML anymore, although the government still uses that on a few major projects. Those are the terms that are being used. And that's what most people think of. That's really the tip of the iceberg. They're really the larger pieces today are enriching that content and using semantics and being able to understand what's in there. And to do that, you need to use artificial intelligence to read documents as if a person is. And then data mining and all these other words that we keep on hearing about. Those are kind of things. Those are kind of tools we use over here. And then we have to validate information. Quality control is a big piece of what needs to get done. When you've converted large quantities of material, how do you know that it's right? Especially if you've automated the process and tried to reduce the amount of manual effort that's going on. So a lot of what we do is develop QA software and use that to figure out if the content is correct. Automation is a big thing of what we do because of the high volumes we're dealing with, and certainly producing well-structured content is the goal of what we do. Not just in terms of the content itself, also today, machine learning, we talk about machine learning needing training sets. Some of what we're doing today is actually producing those training sets that can be used to train machine learning, but also just about many other kinds of applications. Who's the customers? Our customers really cross many industry lines. I think these are the major ones. The reality is that today everybody needs intelligent information in order to be able to operate. And although these industries are very different from each other, at one level, really the technologies are needed are very similar, and one learns from the other. The work we've done in working with defense information has been used for all kinds of technical information. The work we've done in the publishing area in terms of taking upon information has been used certainly in the library world, also in the financial and legal world, and in pharma. So everybody's using large amounts of content today, and having it structured is very, very important. It's mission critical in many of these operations. So today we're going to talk about work we're doing, we have been doing and are doing for the U.S. Patent Office in helping them gain control of the mountains of information that are streaming in there on a daily basis. The Patent Office has actually been operating since the beginning of this country. The first patent was signed by George Washington on July 31st, 1790. It was a new method for making potash, which is used as a fertilizer. It all fit on one page. It was handwritten. I have a copy of it on my wall over here. This past year saw the issuance of patent number 10 million. And today's patents are not on one page. There are hundreds of pages, sometimes even thousands of pages. And patent examiners have to review all these patents. You need to think in terms of the volume that's going in. The patent office gets in 5 million pages of correspondence and filings every month. We are currently processing a little over 2 million of those pages through our automated process. Patents are, security is a very key issue over here, as it is in many of your applications. These are unpublished patents. It's not the patents that have been published already, which are public record, but these are the patent filings that contain a lot of trade secret information, which the patent office has a fiduciary responsibility to maintain as secret. So there's a lot of things that have been built into the process to maintain that security. So security is one, and complexity. There's about 500 different kinds of document types that come into the patent office, which have to be transformed, which we are transforming into a searchable XML, and we do this with no human intervention. Just a little bit about what the documents look like. They're complex. This is a typical page in a filing document. We call it a form, but it's not. It really is very free form, as you can see. This can go for hundreds of pages. It might have chemistry on it. It might have math on it. It has sometimes has line numbers on the side. You know how that would mess up an OCR process. All these things are intended to mess up an OCR process. Not intended to, but they do. There are tables. The tables can get very complex. These are not just a simple table. There's what we call straddled headings at the top. There's math inside the table. There are what look like more traditional forms, hundreds of variations of these. There are, and forms are not today, forms are not filled in. They're not sent to you and you fill them in. They're produced on your computer, so the sizing may be different. Forms, it may be the same form, but the sizes will be a little bit different, or organized a little bit differently, or pushed along in different ways. And there are what we call hybrid forms, which contain all of the above, but also there are signatures that have to be recognized, timestamps. All those things are things that if you run them through just standard OCR process, would get really confused. So to do this, and this is now our fifth year of production, but we designed this. The idea is how do you do something like this and get it to go through without manual intervention. Most production work, and what we've been doing for decades, has at least some steps where people are reviewing the documents at some point along the way, and that's still the traditional way that it's done for publishing applications where you have to have total perfection. But the charter here was do it without human for a few reasons we mentioned. First of all, there's just too much of it. The cost of handling each page manually was not fittable. Would not fit into the budget at all. It wasn't even close. So there was a need to get it down to a lower cost. The other is the security aspects. You don't want 300 people reviewing documents if you don't need to. So the approach we developed was, first of all, the first step was using computer vision analytics, and by that I mean is we have software that analyzes an image and finds everything on the page that's not text. And once it's found it, the software draws a box around that piece and it removes it electronically from the page. So if there's math on it, that gets removed. If there's a chemical formula, that gets removed. Tables are removed, images are removed, and what you end up with And so the first step is that analysis. Step 2 is actually removing that from the page, so that what you end up with is a page that just has text on it and a lot of white space where all those artifacts were. The those pieces that are removed are called artifacts in this process. And that's what the patent office calls them. So once you've got that, you've cleaned up the page as much as you can. Now you can go to an OCR process. With a clean page like that, the OCR works really well. We've been getting better than 99.5% accuracy on most of the pages, which is very good and good enough for this application. I'll explain why in a minute. So the pages are OCR'd. The next step is more of our traditional process of analyzing the OCR that got produced. And for that, we're using techniques like natural language processing, which reads through the pages that we've got now to identify certain things on the page, like when new sections begin, when there's a list to be reviewed, when there's certain terms of art that are used in there that define something about a page. All those are getting tagged and identified. And finally, that's all used to create an XML instance. So XML, as many of you are aware of, but XML is really lets you set up the page with a lot of tagging in it to control it, and to allow you to eventually produce something that looks like the original page. During that step over there, all those artifacts that we took out in page 2 are inserted so that and linked to where they belong. So there's a tag inside the XML that relates to that image that got removed. Other tags are put in there, and that's an XML instance that has enough information to be able to reproduce the page. There's a final step in almost everything we do, which is a quality validation to make sure that everything fits together, all the images are identified, everything fits together, the names are all correct, and a lot of other checks that take place. There's also we also, from the OCR process, we have statistics on how well the OCR got done, and that's also inserted as part of the metadata that goes with this document. It gets packaged together and then gets put in a folder which the patent office picks up from us. This runs 24/7. The 2 million plus pages a month, and it's been running now for it's now in its 5th year. A little bit about how the technology stack is organized over here. One of the issues is that it needs to be very scalable, and it is scaled. You know, the volume we started with was about 1/4 of what it is now, and we had to build a system that would be able to build and be architected so it can build more and more information as it needs it. There's also been there are also rush periods during the year to which, for a short period of time, you may need to double production. So the way we've built this is with separate machines, and these are today, they used to be physical machines. Each one of these boxes would be a physical machine. Today, these are virtual machines that are constructed to be able to do a specific task. And if you look at the top over there, we get information drops into a box, into an inbox at any 24 hours a day. And once it's there, we have software that identifies something came in and brings it into the next available computer. And then it goes through the steps which I already described. It's received, we do some validation when it comes in, and then it goes through the computer vision analytics, artifact extraction, all those steps going through, till it finally goes through the validation to the end, and then gets put into the PTO outbox, which sits on our site, and then it gets picked up. Everything is secure environment over here, so that as mentioned, I mean, there's high security needed for, but this is actually built on a completely separate off the network, so that there's no way for things to get in. This is inspected by the patent office on a regular basis, and all that. There's a NIST 800.53 is a specification for the system boundary that's needed over here. And what this allows us to do is, as we need more processing, we can add on more rows over here. That's, that jagged line on the side. We can add on as much as we need, and it's not exactly one for one. I mean, some of these steps take longer than others. So sometimes they're not an equal number for each of those steps, although it looks like that on this process. Just a little bit of what happens now that they've got all this in XML, and it's sort of like, you got to think, before 4 years ago, I mean, the patent office has been getting these millions of pages a month coming in for decades, and in fact, they've been paperless for decades. All these documents are coming in, get scanned and imaged. And these images get delivered to the patent office, and they get put on a big image, management system, so they can get any of these documents any time. But they weren't very useful, because even though everything was on a computer, a patent examiner still has to go through it page by page and look at it. And today, they can certainly do searching against these, but a lot more than that. One thing that gets done is build a claim tree automatically. So I don't think you can make out, but the left side over here is showing what a claim tree looks like. What that is in a patent there are claims, and these are the claims of what makes this invention unique. So there might be 50 claims, 100 claims, 1,000 claims, and they relate to each other. There are major claims and then claims that belong to each other. And then each of those claims needs to be documented someplace else in this document. So in the old days, a patent examiner, the first thing they would do is they'd open a patent, and then they would draw this claim tree by itself to see what belongs to what and how they are structured. Then they'd have to go through each one of these claims and go deeper into the document and see and make sure that they're all documented someplace. And if they weren't documented, send back a note to the law firm, to the inventor, about how it's not been documented. So this could take half a day or a day, and sort of, you think it's a waste of time for a patent examiner who's a very highly trained individual. So today, all that's done automatically. The software, the analytics that we're doing up front in the process of creating the XML identifies all these claims, identifies how they're indented in different ways to build a claim tree automatically, and then also tries to find where it's documented elsewhere in the document. Since the matching is done on just trying to match the language, that's not always going to be perfect, but we're typically getting 90–95% of the claims identified, which is it's a lot easier to locate the other 5% for an examiner than to go through all of them. So things like that are happening over there. There's a lot of quantitative analysis that's done to evaluate a patent before it even gets looked at, and there's also comparisons done with other patents that might be in the stream. So all these things are things that help the process go along faster. Certainly increase productivity. It used to be, I mean, I just looked at the latest annual report from the patent office. The patents are down to under 2 years. That still seems like a long time, but it used to take 4 years for patents to go through the process. And this year is the first, this past year in 18 was the first year it actually went under 2 years, and it's still been going down. So those are important numbers, and and also it means that eventually they'll be able. Right now, there's about 9,000 patent examiners, which is a lot of people examining patents. Hopefully, that can be streamlined over the next few years. So that's what that's about. Where we are now is 99.6% text accuracy, which, you know, to people who are looking for 100%, that might not seem like a good enough number, and maybe it isn't in some applications. It's certainly good enough for the patent office because that's a lot better than anything that was possible in any other way, but also in many applications, 99.6% is plenty good enough to be able to search and to find things. And the patent examiner has the ability, as he's examining a patent, if he's worried about a typo someplace along the way, something, he can always get. He has the original document available to him at the pop of a button, so he's always able to check that. And this has been tremendous for them. Faster, more accurate review. 2 million pages are unstructured. I've said many times, 0 human intervention, and it's running 24/7. They're able to get these up and loaded. It goes through our system typically in 15, 20 minutes and ready to load onto the patent system. So how does this help you? We've talked about the patent system, which is a little bit different. I mean, first of all, it's very high volume, and there's a lot of automation that took place. And maybe that's not appropriate for everyone all the time, but I think there's some important takeaways over here that help in a lot of cases. I think first of all, there are many high value but impractical projects that people have put away in the last 5 years, 10 years, 15 years, that now with new technology deserve a look again, because there are places where, you know, when it was costing $1 a page or $2 a page or $3 a page or $10 a page, it didn't make any sense. But if the cost is 1/10 of what it was before, 1/20 of the cost of what it was before, maybe those things make sense. I think a lot of those things deserve a look again. There are you know, and what are they? I mean, these are the high volume applications that you might have. It might not be 2 million pages a month, but there are many applications that are much smaller, but still much larger than really people can handle, or are currently being handled, and are just too expensive to operate. And you know, everybody's being pushed for cost, and in many areas of the publishing world, and everybody's a data publisher. Everybody's got this. There's a lot. This is an area where it's one thing if it's all text, and that's relatively easy. But if there's complex content involved, there's there's certainly low levels of accuracy that are available. That computer vision cleanup that we applied changed the game totally in this application and many other things that we've been looking at. And you know, security is not as big an issue for everybody, but it is in many areas. And people are doing financial publishing, people who are doing various kinds of scientific publishing where things need to be kept, or corporate publishing where things. There's a lot of solutions now where it's much easier to deal, because of the automation that's available, it's easier to deal with confidential and sensitive content. And while you know, AI technology, artificial intelligence, is being talked about as something in the future, it's not the silver bullet, like I said before, where you just dump in a pile and everything will work. But we're actively using AI techniques now in many applications, and the key is to be able to structure the information that comes in well. And once you're doing, there's a lot of possibilities that are out there. And that's what I got. Thank you, and ready for any questions if there are some.
Thanks so much, Mark. So if you'd like to speak live with Mark and you're using a headset or a telephone connection, just raise your hand and I can connect you live with Mark. Otherwise, please feel free to write your question in the Q&A box. Just pull it on the left top hand of your screen. You should be able to see that as a control panel. And so you can post your question there. Mark, I did receive a question for you. This person writes that their organization digitizes math equations by making them image files with some alt text. And is there a better way that you might recommend for dealing with those complex math content?
Right, so the traditional way was to create MathML or LaTeX, or there's different languages that structure math so that it can be published in a much better way and can be published and actually can be reproduced. So that used to be, up to a few years ago, everything was being done manually on that. We've been working now for the last year on automating that process. And we've actually been successful in automating conversion of imaged math equations into one of those languages. It's not a language really, but like MathML, which is the math part of XML. And tech, which is a standard language is being used. So there is, it doesn't handle every equation out there. There's some very complex things people can do with math, but I think the possibilities are there, and we've found quite a bit of success in being able to convert math equations. So that is, if it's done that way, it doesn't necessarily need alt text anymore. It can actually be a reader to the blind, or many other software systems can read MathML files, for example, and we're talking about alt text. That's really talking about accessible content for the blind and for the visually disabled. There are readers that can read a MathML file to a reader. So there are possibilities. I mean, it used to be done by hand. It's more and more automated today using artificial intelligence techniques.
Thanks. Thanks for that. We do have Oleg on the phone right now. Oleg, can you hear us? You can ask your question live.
Okay. I'm not hearing anything, so.
I'm not. I'm going to go with a question here. Yes, they asked if the presentation would be available afterwards. Yes, that information will be posted onto Enface's site. So please, we will give you information. We'll send out a video file, but it's also on Enface's site, so you can log in and have access to that. I have another question from the audience here while we're waiting for Oleg to comment. Let me see if I have to. Are you there?
Yeah, sorry. Can you hear me, guys?
We can hear you.
Hello?
Yep.
Yeah, great. Yeah, so I was just kicked out saying to register for webinar and then the meeting. But anyway, so my question was, thank you very much. It was quite informative. What is the technology stack, in terms of the on the ML side, on the machine learning side, if you can share it with us?
I would share it if I knew the details of it, and I'm afraid I don't. I can get that to you. I can get you information on that later.
Okay.
But it's a natural. For what's used over here is NLP, natural language processing software we have, and various algorithms that we've built over here internally. But I can get you more information if you.
Is it mainly Python, or do you know? Is it Python or it's like Scala or Java libraries, or you don't know that this kind of?
Well, first of all, there's Java libraries, and we use Python, and so we use both of those. I'm not sure what's being used over here.
Okay, I see.
Sorry.
Okay, thank you.
Yeah,
thank you. No worries.
Nope, we'll get you that answer. So thank you. Thank you so much. Okay, so I did have another question from the audience, Mark. The question was, do you need to have a specific HTML schema for the content or the data to be useful?
So, I mean, certainly a schema, some kind of schema is beneficial. I mean, because otherwise, how do you structure the information? So there are many other ways. I mean, information is sometimes structured just as Excel files or as different kinds of comma delimited files. So depending on the kind of data that's there are all kinds of approaches. Certainly in what's needed over here, the Patent Office has its own schema over here, which is what we use. But you know, if you're structuring text and you need to keep text together, you need to keep a track of keeping care of paragraphs and headings and subheadings and lists and all those kind of things. So doing it in XML is certainly the easiest way to get this, is that's already built and available. And there are standard XML schemas and DTDs that are available easily. And in PTO's case, they need something more specific, so they built their own. So organizations sometimes build their own, but certainly there are things available that are in the public domain that you can use.
Excellent. Thanks so much. And then last question that I have here, and I would encourage folks in our audience as well, type your question in the Q&A or raise your hand and I can patch you in live. But you had stated, Mark, that the Patent and Trade Office had a lot of complex document types. So in DCL's role, do they help analyze the document types and provide consultation or advice on the best approach for that transformation, or are you just doing the straight up conversion?
No, so they were certainly involved in reviewing documents and collaborating on exactly how best to move documents in. I mean, remember these documents have been there's a lot of these documents are being produced by hundreds of thousands of people out there, and everybody's, you know, don't underestimate the creativity of an inventor, certainly, or of a lawyer when they're trying to put documents together. So there's a lot of ambiguous situations that come up in how do you define something. Certainly, as we designed this, we collaborated with the Patent Office to discuss how this is going to be done. I think the heavy lifting of how do you map information, how it should look, was certainly done by us. But they were very cooperative and very helpful in moving this along, and that's the best way to do it, because certainly the person who owns the data really knows it best. I mean, people in the patent office we worked with have 20, 30 years of experience working with patent data, and I think that's actually a best practices in any implementation, where the end user, the customer, need to collaborate with the developers to make sure that things are done in the best possible way.
Thank you. And I've got another question. So what kind of AI algorithms are you using?
So AI is a broad umbrella. So under AI, artificial intelligence, there are several classes of things that are being done. So I mean, natural language processing is a major piece under that, and there's algorithms we're using under that. Natural language processing means trying to read a page the way a human does, and that's a general class of processing that's done. It's the specifics of how we're doing it over here. The technical details I'm not familiar with. I can put you in touch with people who are, but there's limitations. The other area is machine learning, which is an area that's become more and more important lately. Which is an area. Machine learning means that the computer learns by itself based on information that it's getting. So just sort of the way when you go onto Google and you start typing and it figures out the rest of your question, that's because the beginning of that question has been asked hundreds of thousands of times, and it's looking for the most likely thing that you'll probably be asking. So that's a form of machine learning, keeping track of what people have been doing so that the next time that comes up again, you can apply the same kind of terminology. So that's basically what we're doing in a lot of these cases. When we see a collection of words, what does that really apply to, and what is that likely to be? You know, when you see a combination of letters, is that a license plate, or is that something else? So based on what these patterns look like, you can make determinations. So those are two basic areas that we're working in over there. There's other sub-variations that are in there.
Excellent, thank you. And then I just have one last question. And again, if the audience members want to ask anything, just put it in the Q&A box or raise your hand. But, you know, Mark, this was just such a fascinating case study for the Patent and Trade Office and what they were doing. But are there other kind of similar innovative projects that you're doing that you might just, you know, want to mention, and the solutions that you're solving, you know, for some of these other clients?
Right. So there's a number that we're yeah. I mean, information comes from all kinds of different places. So, for example, there's work we're doing now for a financial institution needs to keep track of compliance information. These are laws that are coming from different jurisdictions. I mean, if you're a financial institution, you operate in all 50 states, you need to keep track of all 50 states as well as the federal government. Working internationally, you need to keep track of all those countries, and those laws constantly are changing. So we've built a process which now runs automatically that goes to each of these websites that belong to these different jurisdictions and takes off the relevant information, that the law information that's relevant, and structures that into a data so that it can be loaded into databases. But then, since those change, we monitor those and run robots through on a daily basis to each of those sites to see if anything has changed. So those are the kind of things that normally would have been done by people. Is a very expensive process, or you don't do it and you take a lot of risk that you miss something. So that's another example, I think, of where this kind of technology works. Lots of other building indexes. I mean, there's a lot of material that's been built over the, for example, indexes that databases have been built over a period of years, and many publishers have, and these secondary publishers have, but they're not fully tagged, so they can't take advantage of what's out there. So we've built processes where we go back against the database and upgrade it to what would be, you know, the latest technology. So, for example, bibliographies, the databases with millions and millions of bibliographies. But if they're just a line item from the back of a magazine or back of a journal article, that's not really indexed very well. So we've gone back in and taken those and then re-index them so that the last name and first name are separated, and the publisher and the date and all those kind of things. So we're upgrading data that was and taking it to a new level using this kind of technology.
Excellent. And one last question. So when you do recognize, do you generate the other possible similar words? If so, how does that affect the accuracy of searches against the recognized data? Does this generate false positives? Does it generate a huge index that renders the search too slow? How do you address that?
I didn't follow the question. Just give me the beginning of that again.
Yeah, it says here, when you do recognition, do you generate the other possible similar words? If so, how does that affect the accuracy of the searches against the recognized data?
Okay, so I mean, we're talking about the OCR, the optical character recognition.
I believe so.
Mm-hmm. Yeah, so I think that's what we're talking about. So, and talking about what happens if it's 99.6% accurate. So that means that there's character errors throughout the document, but you know, there might be 2 or 3 on a page. when you're doing searching on something, if this is being used for searching, that really doesn't affect results very much. We're not making up words in that case. That character will be whatever it was. If it was an I versus a T, that kind of thing. But when you're doing a search, usually relevant information occurs more than one time on a page. So it will still typically find that. This is all, there's a lot of work, statistical work done on this in the discovery space with law firms, which also are never even that accurate with people. So you will find that information. And there are later steps when you're doing things that you could identify things that are you know, likely to be wrong, and those can be corrected. In the patent office case, they've opted, there's no need for that. This is really good enough for their purposes. In the e-discovery, in a law firm, that's probably good enough for their purposes. If you're in a publishing environment, you have to get to 100% accuracy, there is other software that can be applied over here to look for things that are likely to be wrong, and those would be corrected by people. So there's all kinds of stuff that can be done, but I think at that level of accuracy, most things work very well. That's been the evidence.
Okay, I hope we answered your question to the audience member. So if you didn't get your question answered, or if you would like to ask a question that wasn't addressed, please feel free to reach out at Mark, and his contact information is here on the slide. I want to thank today's speaker, Mark Gross. A recording of the event will be posted on the Enphase website at www.enphase.org/lunch-learn-with-Enphase. If you've enjoyed today's webinar, you'll want to visit the Enphase website for more information about other upcoming events. Our next Lunch and Learn program, supporting humane research evaluation metrics for the humanities and social sciences, what role can content providers play, will be held on Tuesday. That was a mouthful. Will be held on Tuesday, March 26th at 12 o'clock noon. Our Humanities Roundtable Conference, Evaluation of Digital Scholarship in the Humanities and its Impact, will be held on Sunday, March 10th in conjunction with the National Humanities Alliance Annual Conference and Advocacy Day. Participants in this event will enjoy a full day of programming at the APA offices in DC, and then they'll meet with colleagues for an evening reception at the Line Hotel at Adams Morgan prior to going out and meeting with members of Congress on Capitol Hill. And lastly, don't forget to register for the Enphase Annual Conference, which will be held in Old Town Alexandria, February 13th through the 15th. And we will discuss and explore strategic solutions to a changing technology-driven marketplace. So this concludes today's presentation. Have a great afternoon, everyone. And thank you, Mark.
Okay, thank you.